This video, we are going to solve applications involving linear equations in one variable. So a linear equation would be something that if we graphed it, it would be the equation of a line. It's going to have one or two variables that are both to the first power. And it's going to be something that's going to be either a horizontal line, a vertical line, or a line with that we would call oblique, that it's somewhere between horizontal and vertical, having some slope to it. These problems right here are word problems that are going to be able to be translated into linear equations, and then we're going to solve those linear equations. So these questions are like those from 6.3, number 31, and 6.3, number 33. And let's go ahead and get started with this. So for this first problem, when a sales representative for a pharmaceutical company drives to out-of-town meetings that require an overnight stay, they receive $100 for lodging. So that's going to be a fixed $100 plus 40 cents per mile driven. How many miles did Joe drive if this company reimbursed him $184 for an overnight trip? So there's my equation. I'm just going to call this 12 because that's how it's numbered on the paper here, but it's problem 31 in the textbook. So 40 cents per mile plus $100 for lodging, and they paid $184. So we should be able to work backwards by subtracting $100 and saying 40 cents per mile that was paid out at $84. Let's divide $84 by 40 cents to see how many miles were traveled. And 84 divided by 4/10 is 210 miles. So the equation was right here, 0.4x plus 100 equals 184, and then 210 miles. That box will get bigger in my math lab as you filled it in. So don't worry, it's a little scrunched up here, but I wanted to use the whole whiteboard to work on it. Now let's work on number 13 here on my paper, which is problem number, it's like number 33 from the textbook. Set up an equation and solve the problem. At a boating and sports store, the cost of running the personal watercraft is $58.30 per hour, which includes 6% sales tax. Determine the cost of a half hour of rental before tax. So let's go ahead and say that this is equal to, and it doesn't matter how much how many hours or whatever, it's always going to be 6%. So we'll figure out the 6% sales tax at the end. But I need to, if this is for a full hour, I need half of my hourly rate is going to give me 58.30 divided by 2 would cost me 29.15 for the half hour. And then I'm going to say that this is 106% of something is 29.15. So I'm going to divide by 1.06. And that will give me X is $27.50. Now there's another way that I could have solved that problem, that I could have found the hourly rate before tax and then taken half of it. And let's see if that works as well. So if I say 58.30 is 106% of something, and X is 58.30 divided by 1.06, and that would have given me $55 an hour before tax. But I really want half of that because I only want half an hour. So half of $55 is $27.50, and I get the same answer. Okay, so a couple of different ways I can find half of the rate after tax and then find what the rate before tax of that half hour was, or find the hourly rate without tax and then take half of that to get the price for a half hour. So next time we are gonna come back and do an application problem that involves proportions. I could have done this one with proportions, but we weren't supposed to do it that way. So we'll come back next time and we'll use an equation with a fraction that's equal to a fraction called a proportion. We'll have a special way of solving those. So I'll see you for that next video, which will be the last video for 6.3.